talk is about venturing beyond the 12 factors, so taking full advantage of what the advice it gives and the best practices so that you can be, your applications work better in the cloud. That's what this is all about. So we already gone over the introductions. So this is where we all get intimidated by going to the cloud, but you guys are all there, so not a problem. So why do we move to the cloud, right? So there's all these things that are promised. Cost, that's debatable. I think we all find that out. Scalability is a big. Fashion, it's good to be on the cloud. If you're in a company, it's good to be on the cloud. Flexibility, once you're there, you have take advantage of other cloud technologies that come on board. Resiliency, speed, innovation, all those key things. So we all have the right reasons for going to the cloud. But then comes the hard part. We're on the cloud. So how do we act? How do we take advantage of what the cloud has to offer? So these are the best. This is like a word cloud. These are the things that we should expect out of our applications once we get to the cloud. These are the advantages you have over being local. Okay? This is what we should strive for. The big key we're going to talk about a lot today is loosely coupled. Right? That's going to be a key theme throughout. Scalability, another one. So based on demand, we want to go up and down. Observable. We need to be able to determine how our services are doing. And if we do all that, it's going to be resilient. We're going to have speed. It's going to be robust. All those great things. So let's get started with that. So the 12-factor apps. So this was developed, I think, over 10 years ago by Heroku, which was a cloud provider, one of the earlier pioneers. And basically what they found out was as they were platforming a lot of customers, they found out the best practices. They found the people that didn't do them well, failed. People who did do them worked just great. And they wrote a book, 12factor.net, or actually it's a blog or an article. But you should definitely look into this. We're going to talk about all the 12 factors, but this is going to have a chapter dedicated to each, and there's a lot of detail. We're going to try to get you a little feel for what's involved. So here are the original 12 factors, in probably the order that you would need them as you're building out your applications. Right? We have the code base and how we want to handle that with repositories and such, how we label our dependencies or how we set those up, configuration, backing services that all applications need, the whole CI/CD process, how processes should behave, how we export our services through ports, concurrency, this is talking about scaling up and down, microservices coming up and going away, disposability. Dev prod parity is going to be interesting. This is how we set up our environment so that everyone works the same. Logs and admin processes. So with all great methodologies that were written 10 years ago, there's updates, right? So now there's the 15 factors. I'm going to go back one. Does anyone see anything that's obviously missing from here? Security, yes, that's right. So these are the new revised factors. There's a link here. Basically, it's taking those, it's further refining them, defining them, and adding some new ones. And I'll see, here are the new ones right there. So API first, telemetry, and authorization and authentication, which is basically security, which is a big hole in the original 12. And again, that's a link to finding out more. Let's start going through these. So they're labeled with the number that's from the 15 factors, and here's the original 12 factors. I'm not sure why we did this; it kind of confuses people, but I think we're just going to cover them all. So just keep that in mind. So code base. Oops. One code base for your application. Everyone comes from the same code base. It's stored in a repository. Everyone's checking in and out. I think most people do this, have this handled correctly, right? So you have one code base for multiple deployments. So everything comes from the same code base, whether it's going to QA, whether it's going to release, production, testing, it all starts from the same code base. You don't have Q&A using that code plus something else. Everything comes from there. And the tools, and along this way, I'm going to point out some tools that help you manage this process. And in this case, obviously the big one's GitHub. There are others. So dependency management, basically we're talking about explicitly defining what your dependencies are, locking those down to version numbers. It's very, very important. Don't just pull from latest. Depending on when you pull it, you may get different code base, right? So those are all defined. We have some good tools for that, Maven and Cradle. You set up your file, specific release version numbers. Everything you need needs to be defined there. Everything's external. The design, build, release, run. So these are all the stages in your CI/CD pipeline, and they all have to be distinct, apart, but they feed each other, right? So we start off with a design, talking about something new we want to implement in our application. We have a build process that goes through and takes all those dependencies, builds that binary artifact in a WAR file or a zip file. The result of that is then moved to release, where we can inject some configuration, and then the cloud platform will deploy that out. Tecton's a good tool for that. Also Jenkins, I think. Anyone use Jenkins? Configuration, credentials, and code. Nothing should be in your code. Everything should come externally from the environment. I don't know if you can really see all that, but all passwords. Can your code be open sourced? Do you have password keys in there? You should have none of that stuff, no links to anything specific. It all should come from your configuration that gets injected at release time.
If I may add something.
Yes.
Here. So in my 20 plus years of experience, one of the main challenge which I faced is around figuring out where the control factor is changing. I debug some code. I don't know where things are changing. So the code and configuration was intertwined heavily, and it takes a lot of time to figure out and separate those things. So one of the main ingredients of the 12 factor is separation of code and config, so that we precisely know what are the controlling factors and what the code is doing. So you can focus on the code and you can focus on the configuration separately.
Yes. And MicroProfile, has a config component where you can inject from property files into your code. Everyone familiar with MicroProfile? No one. Okay, so that's open source from Eclipse Foundation. It's basically a lot of set of APIs to help you build microservices. We're going to touch on MicroProfile a lot today. Being from IBM, we definitely encourage use of this standard because it is open. You're not locked into anything. Multiple companies are contributing to it. There's, I think, MicroProfile version 6 just came out recently. So they're constantly trying to address the community, what needs they have. One of them is, how do I handle my configuration? So they've added that as part of their spec. The other important thing is it's just a spec that needs to be implemented by different runtimes. So not all runtimes are equal. I'm again from IBM. I support Open Liberty. We have just implemented this spec. We're always the first on that to do that, but the others will come along. So logging. So everything from your application, your services, should just spew out to standard out or standard error. Right. That's all you care about from your application standpoint. There are other tools that will then take that information and make it readable and format it for you. And there's a lot of tools in this space to help with that. Your cloud platform will help. We have Elasticsearch, Logstash, Kibana, things like that. So if you notice, there's a lot of tools, a lot of vendors that come on and they understand the problems that people are finding when they're building microservices. And they're building tools to help. Disposability. So this is regarding your microservices. Just be ready to plan to have things come and go, right? So you start fast, you can clean up well. Just be ready to be scaled up and down. That should be the life of your microservice. And what we're trying to emphasize here is that these are microservices. They're just numbers, right? Over here is Carl the cat, which means we've named him. We care about him. We're going to nurse him back to health. We don't care about that, right? We're all disposable. Be ready to come up fast and clean up. Again, MicroProfile can help here. Backing services. So we're all going to attach to different, for example, databases, other services. Those should all be treated as separate services outside the scope of your application. Those are just treated as just resources you have access to. You're not going to tie into defining what the resource is from your application. You're just going to make a request for something and just count on that backing service to be there, right? Environmental parity. So development, QA, production. So I think we've all come across, any testers here? None. All developers. Okay. Well, if you're a tester and you find a problem, the worst thing you can go to is the developer. He says, well, it works on my machine, right? That always happens. And the problem is because your environment's different than theirs. So you really need to try to make sure that all the environments are as close as possible. So you may not be touching the same databases, but the connection will be, the connection needs to be the same for both, right? One may be a stub, one may be talking actual data, but the connections have to be the same. You need to line all that up so that every person in the process that's going to touch this code is in basically the same environment as everyone else.
Yeah, the pre-microservice way of doing things is set of developers develop things in a specific platform which of their comfort and then pass it on to the testers. They do it on different set of platforms with their own comfort and then report a lot of issues, and then you have a lot of false positives, and a lot of developer time is spent in to and fro between the testers and developers because they don't see the same thing just like in the same platform, same configuration, same environment. So with this specific ingredient, we are trying to resolve those sort of problem of disparity. Everybody sees the same picture. Yeah.
I heard you, but
okay.
And if you've done everything right up to this point, this should be very easy to do, right? So the testers will get their release out of the build, which has been built the same way for the process for actual release. All the configuration comes from externally. All the external dependencies are defined in the POM file, so they should be able to run it. They should get that. Here are some tools that help with that: Docker, microshed testing and test containers. So administrative processes. So these should be external to your application. These should be one-offs. Now you can put the actual tasks that you want to perform by administrators in your code base. That's a good place to have it. But they shouldn't be accessed by anything else other than an administrator logging on and performing it through Kubernetes tasks, I think, is one way. Let's see if do I list any other tools? No. Also, AWS Lambdas, some one-time event to go and query to find out the state of your process. But it's important to separate those out. Port binding, everything is defined by a port. We never talk about domains or IP addresses or anything like that. Kubernetes MicroProfile has ways to help with that. Stateless processes. So everything is stateless. Process B never needs to know what process C is doing. It's just passing on requests. So no one needs to know what anyone else is doing, what state they're currently in. We handle everything, data transfer through REST, but we need to keep those separate. Concurrency, this is about scaling up and down. Now this is basically handled by the platform itself, right? So if you're set up, your microservices start up and they dispose of well and they can scale easily, this is going to work out seamlessly for you from the cloud platform. Kubernetes is the orchestrator usually to handle that. So API first. So this is a big one. So what it's trying to tell you is APIs are very important. They should be locked down and fixed. Everyone's going to depend on them. You create a microservice. You don't know who your clients are going to be eventually. You need to define what your inputs are, what you're going to return. I think we're going to show there's Open API, MicroProfile have good ways for you to annotate your REST service so that it's available through some Swagger. Everyone available understands Swagger, right? That UI is pretty clean. So you get your APIs settled up front, whether they exist or not. You figure them out early on. You define what they're going to be. You set up contracts on those, and anyone that's can subscribe to those, it's going to use them. And so everyone knows what happens when you change those, right? So that's a big deal. You don't want that happening under the covers and all of a sudden your application doesn't work. You don't know why. So API first is huge. Telemetry. This is just an extension of logging, but there's some additional information that microservices can provide to orchestrators like Kubernetes about your health. So MicroProfile has a really good scheme for that, where they can message out their health and metrics so they can be tracked and monitored. It's very important. Authentication and authorization. Again, this is all about security. Everything has to be associated with roles. Everyone understands RBAC. Okay, yeah. So it's basically assigning who can do what when, right? So that has to be a big part of your system. Just don't give everyone root. That was one of the big things I liked about OpenShift when it first came out. Was initially most platforms the default was your root. You create a container, go for it, right? OpenShift really locked that down. Your default is you can't do anything. So you have to ask for all these permissions. An administrator has to set up an account for you and then assign you some capability, which you then use. You get to the next step and you say, well, now I can't do this. So they keep adding to you just what you need, right? That should be the goal. That should be the process. So the five-factor apps play a part in the whole CI/CD pipeline. So over here we have our pipeline. Here we have our image repo, maybe Docker Hub. We have Artifact repo. We also have Maven Central down here. Here's our app deployed. So over here is our actual cloud where it's been deployed. We have an app with a microservice, and we have some outside dependency there on some back-end service. And now we can throw in these 15 factors now and what part they play in this process. I know it's kind of hard to read, but we start over here with a one code base as a feed into the pipeline. We have our defined processes that Tecton's going to handle. We've defined our APIs first over here. Artifact repos, image repos, and our app that's actually running now is pulling in the configuration from some other place in the environment. We're accessing our microservices through ports. These are all stateless. These are decoupled. Concurrency, disposability, we can go up and down as needed. We're logging. We're sending out telemetry. Here's an external process to query what's going on by the administrator. And we talk about some of those capabilities or attributes we'd like to see. That's where they come into play. Whoops. There we go. Sorry about that. Notice these are loosely coupled, these two applications. Observable, meaning we're doing the telemetry and the logging. rapid deployment through our CI/CD pipeline. Oops, but we had one more. Apparently we don't. Okay, so we talked about the 15 factors, 12, 15 factors, and we mentioned a lot of tools along the way that help you get there. Gireesh is now going to talk about some more frameworks that help you along this journey.
We heard about the 12 factor and the 15 factor, the cool things that enables the cloud native framework to run efficiently and optimally. Now let's look at some of the tools and frameworks and technologies in reality which would actually help you developing and deploying cloud native applications optimally. So first one is the Jakarta EE. Anybody knows about Jakarta EE? Heard about that? Okay. So basically, before talking about Jakarta EE, let's talk about some of the premises and the problems in the Java development deployment world. Originally, we had the issue of the lack of capabilities itself. So if you look at the Java SE, the standard edition, it provides you with a set of APIs which are good for printing SOPs, accessing files, accessing network, and accessing all sort of hardware devices, writing toy applications. But that's all fine when you're building small. But when you scale to the enterprise grade, you need capabilities to the extent of hosting a web application, connecting to a database, translating some of the data formats, parsing, serializing, and so on and so forth. So the capability expectations are huge. So that's where J2EE or Java Enterprise Edition came into being. But later, with the exponential growth of the Java ecosystem, J2EE grew into various versions like 2, 3, 4, 5, 6, 7, and 8 with a lot of additions in all these enterprise areas that we talked about. So that's about the feature or the capability. Then when it comes to enterprise, there are other aspects which we need to consider. Number one is the security, compliance, and standards. Number two could be performance. When millions of users are accessing your application, it should be able to sustain with the same level of throughput and performance. You should have diagnostic capabilities. When your application is crashing, you should be able to isolate, recreate, identify the problem, and provide a resolution in the quickest time possible. So diagnostics is a huge aspect of the enterprise aspect. Then we talked about the compliance. And another one which over the time which we identified is the vendor lock-in problem. Like these are good capabilities one vendor is providing, it's meeting your expectations. But what happens is when you want to migrate or when you want to change your code, then suddenly you realize that that's not possible with this particular piece of code, and you look out for another software for another vendor, but then you soon realize that many part of your application is going to break if you change that specific route. So vendor lock-in is a big problem. So over the time we have seen that open source is the single answer for that, where you don't get into vendor locks, you get all the code that's available in your favorite repository. And now that's fine. That has been the norm for last 5, 6, or 10 years. But then we have a new problem. You go to your favorite repository, Maven or whatever. For Node.js, it's NPM, largest repository in the world. You search for the capability, you get the code, you run it, no problem. But then there is a problem, there is a security issue, or there is a functional issue. You report it to the community. There is nobody to take care of that. Nobody is responding. There is no maintainer in the community. The feature was good, but without the bug fix, you can't move forward. So the open source really requires a stability and maturity. So you don't just go and grab any piece of module that, of your interest, but look at which are the stable modules, which are the long-term supported modules, which have a maturity attained over the period of time. So Jakarta EE tries to address all these things in under a specification called Jakarta Enterprise Edition specification. Talked about community-driven collaboration, open innovation, no vendor locking, transparency, and to be able to meet all your requirements in a sustainable, in a long-term manner, right? Now, how do you achieve that? You should have a strong community which has set of members who have vested their interest in the Java ecosystem over a period of time. So that's what we see in the members of the Jakarta EE community. We have strategic members who have their huge part of the mission depending on this specific ecosystem. And then you have enterprise members, participant members, and so on and so forth. Now, these members invest in the community, they deploy personnels and skilled engineers, and they take care, they make sure that they are taking care of the ecosystem to the best extent possible so that the developers and the business who are depending on Jakarta EE do not get into any sort of problems that we mentioned. Anything you want to add, Rich, here?
Did we ask if you guys know what Java EE is? Has anyone used that in the past? So Jakarta EE is just taking that to the next level, and it's open source by Eclipse Foundation,
yeah.
Right? So that's all that is just taking it out of when it was all that was open sourced and Eclipse pulled in, and it's got these members, and it's really important to remember that these are big companies that are investing a lot into that. I know that we have at IBM we have members, official members in the board that are part of the direction, and we're vested to make sure that this works, and we put it in all of our products, so it's not going away.
Yeah. Okay. So with the introduction of Jakarta EE9, the major change is the Java X package have been renamed to Jakarta.star. Essentially, this is a technical change because the Java Enterprise Edition, the copyright, and all the paraphernalia of that has been shifted from Oracle, who have been holding the whole thing, to Eclipse Foundation, and I guess the Java trademark is owned by Oracle. So we couldn't use the Java keyword anymore in those packages and the dependencies. So everything is just renamed to Jakarta.star. So just keep in mind when you're using those modules, don't get surprised by seeing that this is whole sort of totally different thing. It's just the enterprise edition of Java itself. Yeah. So this is the whole gamut of Jakarta EE spectrum. The whole idea is to support Java developers and deployments to the best extent possible in a big gamut of software capability, from batch applications to web applications to database centric, computation intensive, event driven, messaging type, or scientific missions, or anything that you can talk about, anything that you can think about in the modern workload scenarios. So Java EE is an evolving set of technologies and specification which tries to capture, which tries to modernize itself over the period of time by getting the best from the industry. One of the best example is the event-driven messaging systems, because there is a lot of focus on the event-driven thing, and now Java want to adopt that, Java Enterprise want to adopt that. There is a lot of workload that actually could benefit from being event-driven rather than the traditional way of CPU-driven. So I don't intend to go through each one of it in detail, but yeah, this is the whole set of enterprise capabilities. So we talked about the feature and the capabilities, which talked about the enterprise enabling factors and things like that. There is one side effect or one one aspect that we did not talk about that. So when your application grows over a period of time, it really grows into a monolith, right? So when it comes to the microservices, which is the norm of the modern day workload and programming, how do you deal with the complexities, right? So think about an application which is tiny enough, like few kilobytes or few megabytes in size, but it has a dependency on a huge enterprise module, like say JSON.zip, which provides you with a complete set of capabilities related to the JSON, which provides you another module which covers the whole gamut of the web profile. So what happens is your application grows quite big. Even though your code is a microservice, the dependencies are quite huge, right? So you need a profile, you need a customization of the Jakarta EE, which best fit for your microservice philosophy. So you need a curtailed version, again aligning with the open traditions, aligning with the latest and greatest capabilities in the microservice world, aligning with all the 12 factors and the 15 factors that Rich talked about. We need all the cool features, right? So the answer to that is the MicroProfile. You want to add anything? I'm
Nope.
just trying to define the most fundamental form or the basic definition of the MicroProfile. Yeah. So we don't want to miss out on why MicroProfile. What is the difference between MicroProfile and Jakarta EE? Are they one and the same? Is it a superset or subset kind of a thing? It is the same Java, but it is heavily customized for cloud native microservice development life cycles. So optimized enterprise Java for the microservice architecture. You could see that you are using dependencies the minimal level possible. You are able to apply the 12 factors and the 15 factors to the best possible extent throughout the design aspect of the MicroProfile. Let's have a look at that. So again, the definition, it's an open source community specification for building Java microservices. Largely when we talk about a specification, we will have a specification document which elaborates on the objective, the design and the plan and the overall scope of the whole technology. Then you will have something called a TZK, which is a technology compliance kit. This I'm talking about the Jakarta EE, not the MicroProfile. So anybody who is implementing the specification should pass the compliance kit to be called as a Jakarta EE compliant. Then you should have the components which align with those specifications. So these are the active contributors who actively work on the MicroProfile in the community. So it's completely open, collaborate through GitHub and try to implement each one of the MicroProfile specification in one runtime or different runtime based on their interest and based on their choice and interest. Anything, Rich, you want to add here?
No, I think it's important to note the players involved, right? Open source is not always the same. So you have major vendors who are resilient or need to be involved in this and are, I think they're going to guarantee the future of the spec itself.
Yeah, the major vendors again assures that the code, the spec is up to date with the latest, and it doesn't cause any sort of vendor lock-in. It doesn't cause any sort of problems that we mentioned in terms of the stability and maturity that we have spoken in the open source world as well. So these are the Java runtime, application platform runtime implementations, which adheres to the MicroProfile specification at the moment. Are they all on the same maturity curve, Rich? Do you know?
I know that No, they don't. I know that Open Liberty implemented the Jakarta EE10 and MicroProfile 6 the soonest. I think they did that within the last month, but they all will get there eventually.
So one of the cool thing with the MicroProfile standardization is the fact that today, if you implement a piece of code, a microservice implementation, one of the runtime, tomorrow you want to move between the runtimes, it's just a no operation, just lift and shift to the other one, no change in the code, no change in the configuration, it just work like magic because everybody adheres to the same spec. So this is the MicroProfile 5.0 stack look like. Now this is a very important, very critical, very interesting slide. If you recollect what Rich taken you through the 15-factor microservice specification or microservice recipe, you can actually see most of it featuring here. Starting from the base stack of a web profile with the JAX arrays and the CDI and things like that. So the bottom layer defines the bedrock of the microservice capabilities. Then you come up with the middleware like the Open API, one of the new proposed 15-factor. Then you have the JWT, the configs and things like that that lie just above the foundation bedrock layer. Then you have the next set of enterprise capabilities, again featuring in the 15-factor, like the open tracing, the health and the metrics, which is critical for any large-scale microservice to function and to be able to be observable properly. And you have set of standalone projects which basically can be used as is for any other applications. So this stacking is important. This concept and understanding really becomes important when you are developing things from scratch to see what are the capabilities that it incorporates and what are the things that would be useful for your particular scenario and how do you leverage that to the best possible extent. So in other words, MicroProfile defines a set of standards and provides implementation guidelines for Java runtime for microservice application development by completely or aligning to the best possible extent with the 12-factor recipes or the ingredients that we talked about. You don't need to implement by hand because you have the framework and tool that's already available. That's the key learning. Open Liberty is a cool Java application runtime engine which adheres to almost all of the MicroProfile specification. It inherits its legacy from WebSphere Liberty, which in turn inherits from WebPeer, which is 25 plus years old. And one of the main learning from WebSphere over the time has been how do you scale, how do you diagnose, how do you implement the performance, and how do you address most of the problems that is addressed in the field. So that has completely been inculcated and applied in the Open Liberty to the best possible extent. So Open Liberty is 5 years old now. In 2018 is when we realized the need for refactoring the WebSphere to tune to the requirements of the cloud native world, cloud native philosophies, and we could actually align most of the philosophies into this implementation. So some of the coolest features here is focusing on code, not necessarily other aspect of the application, and able to make changes very easily because the code and configuration is separated, and you have ability to write tests very easy, and we have plugins and extensions that we implemented to make it full development lifecycle completely without leaving your favorite IDE, whether it is VS Code or Eclipse or IntelliJ. you have the connectivity with the container. You have the ability to test and debug everything in just like in any other application.
Briefly talked about, so Open Liberty. So everyone knows what WebSphere is, right? It's been around for 25 years. Anyone? No? So Open Liberty is the next generation of that, built for microservices and cloud native applications. I do want to show you the environment, which is probably the best selling point. Besides the fact that it is the early adopter of the specs we talked about, Jakarta EE and MicroProfile, it's first to do that. It is a runtime, and we talked about all the 12, 15 factors. I don't know if you noticed, but we had at the bottom were the URLs pointing to guides, and this is the key point. So let me get out of here. Hopefully it's still up. I tried getting this environment when I was sitting around, see if it's still there. Hopefully. All right. So openliberty.io/guides. This is where we have about 65 to 70 guides set up, all written in Java, that tell you how to implement some of these features we've been talking about. On the left, gives you a little index of the things we try to highlight here. We talk about RESTful services, React services, configuration. So the fact that we talked about you want to keep things configured from externally from your environment, and MicroProfile has some features that allow you to inject in your code. Well, that sounds nice, but how do you do it? You would come and look at one of these guides. And what's really great about these guides is that you can run them in the cloud, meaning you don't have to download anything to your system. There are prerequisites, so if you want to run them locally, you can. You have to download Maven and you have GitHub and you got to pull down a zip file, or you can just say, let me just run it in the cloud. Not all of them are available that way, but most of them are. And when we say run in the cloud, you're going to get a sandbox in the IBM cloud. It does require a single sign-on login so that we can track you. Previously, we didn't, and people were abusing that. But you log in with single sign-on account like GitHub, LinkedIn, Google, and you'll get access. And when you do, for example, like here, you say, I want to learn how to just get started with Open Liberty. You'd run in cloud. It'll take you to the Skills Network Lab, which is what I'm showing here. Hopefully it's still running. It does time out after a while. But the setup is really cool. It's got instructions on the left that take you through the process. On the right is your IDE, right? You've got your File Explorer, you've got terminal windows. And as you go through it, it'll tell you what you're learning. It'll tell you to inject code into here, write the code so you can read what's happening, you get a feel for what's going on. The interface is really cool. It's got this little do it button, basically. So it tells you, you need to CD the home directory. Well, you can just click that button and it just happens in your terminal window. You need to get clone and then CD into your MicroProfile directory. You just hit the button and it just happens. It was quick there because I already downloaded it. The Liberty itself is an application server. You can run it many ways. In this case, we're showing running it in the foreground. Then you would just stop it. You could also run it in the background. You can run it in containers. And you can also run it in dev mode, which is really a nice feature. So dev mode means it's going to sit in the background and it's going to have triggers to all your code and configuration. So anytime you make a change anywhere, it's going to automatically restart your server for you. So you don't have to worry about that as a developer, which can solve a lot of headaches. So this particular guide takes you through the process of learning how to start and stop your server, generating an open API document for the service. I hope I have this running because it does create the one other thing I want to tell you about. If you go into there's two directories. Every time you pull down the GitHub repo, you get a finish directory and a start directory. So the guide will take you to building your start directory, which is going to end up with the end result, or you can go directly right to the finish, and all the code is already there for you. I don't think this is going. I've gone too far, a couple places, so it's probably not going to work out. But anyway, we have 15 minutes left. I could start trying to do this. Any questions or anything that?
So, Rich, what do you call this? Is it a documentation manual or a IDE editor or a deployment target? For me, it looks like everything in one interface.
Yes, it's a really nice interface. It looks kind of cramped on my little laptop, but if you have a nice environment, it's really easy to follow along and learn everything you need to know. And the IDE is VS Code, so everyone should be familiar with it. And like I said, the key part is the ease of the UI, but the other part is that it's going to take you step by step to understand how to implement the things that we talked about, the 12 to 15 factors. So it's easy to read a paragraph about how you should do it. It's another thing to look at the actual code, and here are the API calls that he was telling us about, right? MicroProfile has implemented a spec to do the open API. Well, how do I do that? Well, here you go. Here are the annotations and how you set it up, and I go out to my Swagger interface, and oh, there it is. That's how it works. So it's really cool. It's invaluable. I know that I talked to a lot of the speakers who are talking about, they say the Open Liberty guys are just really an advantage if you want to learn. And you can learn about REST, how to create REST interface services, all the things we talked about. Everything that MicroProfile, we're really big proponents of MicroProfile if you haven't picked up on that yet. So we try to show examples of how to do that. We get into security with JWT tokens and things like that. So anyway, I just wanted to make sure you all knew about that. It's openliberty.io/guides. It is available to everybody. Thank you very much.
Thank you very much.